This is problem 24 from the Chapter 11 review. It states, find the rectangular coordinates for each point with the given polar coordinates. Round answers to the nearest hundredth. All right, so with this one here, we've got the point -10, 2 pi over 11. So we're trying to find our x and y coordinates given our polar coordinates, which is obviously the radius and the angle of rotation for theta. Okay, so just so we're looking at kind of what's going on, these ones are probably, I don't know, to me a little bit easier to do than the one you just did on number 23. Just to kind of give you an idea here, let's just go ahead here and we'll just kind of sketch this out real fast. Okay, so a sketch isn't even required on this one. Okay, if you think about 2 pi 11ths, right? So if we went 2 pi 11ths, well, 2 11ths is pretty sure it's like, somewhere over here in the first quadrant. So, right, so we got our angle, and this might even be big there, but it's fine. So this is like where we're at. But since it's -10, right? So if we were rotating out here to 2 pi 11ths, right? But our radius is -10, that means it's going to be back over here on the other side, right? So that means that this point, just so we know, right, is down in quadrant number 3. And when you think about your x's and your y's down here in quadrant 3, right, they're both going to end up being negatives in this case. So that kind of helps you there as you're trying to figure out what your final solution is going to be. Now, there are some relationships that we've built in this chapter when we're talking about our x's and our y's and our r values, right? We said that when we're taking this here and we're using our hypotenuse as the radius, with this being x and y, and this being kind of like our theta, our reference angle, what we said here is that we talked about the cosine of theta was going to equal x over r, and then we found our equation for, sorry about the calculator there, we found that our x value, if we multiplied both sides of this equation by r, we get that x equals r times the cosine of theta. And then similarly, right, we said for our y's, we said if we talked about like the opposite here over the hypotenuse, if we said the sine of theta is equal to our y value over r, and then we multiplied both sides times r again, we would get that y equals r times the sine of theta. Well, when we're converting here from polar to the rectangular coordinates, okay, we can use these formulas. We already know that the radius is -10, right? And we know that our theta, or our angle of rotation, is 2 pi over 11. So we have what we need to be able to come up with these points, our x and our y coordinates, already. We're just going to use those two formulas here, right? So we're trying to come up with our x and our y. So to do that here, if we look at our x, since x is equal to the radius, which we'll say is -10, right? That's coming from down here, times the cosine of theta. So times the cosine of our theta, which is 2 pi over 11. Now, something that's really important here, if you're going to type this in on the calculator, you need to double check that you are in your radian mode, because our angles are given in radians. So when I do this now, I'm going to say -10 times the cosine of 2 pi divided by 11. And the answer I get there is -8.41 when I round to the nearest hundredths place. So we have -8.41. That should be our x coordinate. And then we're just going to find our y coordinate. Same way, we're going to do Negative 10 is our radius, now times the sine of 2 pi over 11. And we'll see what we get there. So let's just do negative 10 times the sine of 2 pi divided by 11. We hit enter there, and you get about negative 5.41 when we round to the nearest hundredths place. And now that we have our x and our y values here, right, that means we found the rectangular coordinates of this point. This point is going to be negative 8.41, comma, negative 5.41, which makes sense, right? That would be down in the third quadrant down here. All right, that is problem number 24. We were switching from from polar to rectangular on this one. If you have additional questions, please make